and y-intercepts. So finding x and y-intercepts here is no different than how you find them any other time, but we can make some notes about what will make that process easier. So how do you normally find an x-intercept? Good. Okay, so we set y equal to 0, and then we solve for x. So we get these points where there's like an x value and a 0 for y. And depending on the type of function we have, different amounts of x-intercepts. If you have a linear function, what are the maximum amount of x-intercepts you're going to have? 1. Is there any way it can cross through and come back and cross through again if it's linear? No. And you might not even have one, right, if it's horizontal. Okay. What about if you have a quadratic? What's the maximum number of x-intercepts you can have? 2. What's the minimum number of x-intercepts you can have? 0. Can you have 1 also? Yes. So there's no, don't get freaked out if you get 5 of them versus if you get none of them. It totally just depends on each individual function, right? So just a note about how that's going to work now that our functions are more complicated. Let's say that the function that someone gave you looked like this. All right, right. So this is why I mention it. It's really not as bad as we think, but when we set y equal to 0 here, and then it's time to solve for x, people are like, yeah, right. But it's actually not that bad, okay? You have a fraction on this side, and you have 0 on the other side. When will a fraction equal a value of 0? Okay. Only if the numerator is 0, right? If there's no 0 in the fraction, is it miraculously going to divide out to equal 0? No. If 0 is in the denominator, is it going to equal 0? No, it's going to be undefined. So the only way that this function is going to work out to equal 0 is if 0 shows up in the numerator. So really, we can kind of give ourselves a little type of shortcut, is we can just focus on the numerator and set it equal to 0, and that would solve what we needed to solve, right? We're really doing the same thing we've always done to find x-intercepts. I don't want you guys to think there's some special procedure now. It's just that we want to make it less complicated for ourselves, right? Setting this crazy thing equal to 0 is really just when will the numerator equal 0, which in this case there would be 2 x-intercepts, right? One at -3, because that would make 0 in the denominator, or the numerator, excuse me, and then also 1 at 1, because that would make 0 in the numerator. Are we okay with that? All right, what about y-intercepts? What do we do? Good. Okay. So we'll set x equals to 0. We'll solve for y. And then we'll get points where x is 0 and we have some y value. Now, if something is truly a function, how many y-intercepts can you have? Maximum. See? 1. Okay. Anybody know why? They're all over it every day. They're awake in the morning. The rest of the time. All right, Keelan, give it a shot. Good. So think about it in terms of the vertical line test. If something is truly a function that says every time you have an input, some x value, you only have one output that goes with it. Well, 0 has to be the input if something's going to be a y-intercept, right? So if it's really a function, maximum you can have 1. Is it possible to not have a y-intercept? Yes, we've seen things where the vertical asymptote is at 0, something like that. Maybe we'll have a hole at 0. We don't know, okay? So it is possible to not have 1. It's possible to have 1. To have more than 1 has happened before when we graph things sideways parabola, circle. But are those things functions? No. What we're graphing are going to be rational functions, which means they should follow this rule of having a maximum of 1 y-intercept. Okay? All right. So we're going to graph some stuff. All right? All right. This is the first thing we're going to graph. Okay, I'm going to make a list of all the things I'm going to find ahead of time that are going to help me create a structure for this graph to follow. So basically, I want to know if there are vertical asymptotes, horizontal asymptotes, oblique asymptotes. Are there any holes? What about X-intercepts? What about Y-intercepts? All right. A lot of information, but again, better than just making an XY chart in this case, because we saw just through a couple of examples that the book gave us that these graphs can be shaped in lots of different ways, and we kind of wouldn't really know without figuring some of this stuff out. All right. Asymptotes. What do I want to look for? Somebody tell me, okay, to look for this kind of asymptote, we need to look at this about the function. I see Zeke's hand. I'm not ignoring him. I just want the rest of you to wake up. I know it's right. Hey.
To factor out a 2 on the denominator to see the number that 2x in the denominator to see what the number that you're adding or subtracting to get the vertical axis.
Good. Okay. So when I factor the denominator, I would get 2x squared times x plus 2. And if I multiplied that back out, I'd get this. What asymptote is he looking for when he's focusing in on the denominator, factoring it, and trying to see when it's going to equal 0? What asymptote is that referring to? That's the vertical ones, right? He's looking for places where the function is undefined. What are the values right now that would make the function undefined that we can see once we've factored it? See? Good. Okay, so we're going to have one vertical asymptote at x equals 0 because that's one possible value where the function is undefined. We're going to have another vertical asymptote at x equals -2 because that's another place that the function could be undefined. Okay? All right. Does the numerator factor? No. Okay. Do I want to look to see if it factors? Yes, because what's going to happen if a factor cancels out of both numerator and denominator? I have a hole. Do I need to know that? Yes. Okay, so I definitely want to think about it. In this case, it doesn't factor. So do I have any factors that cancel from numerator and denominator? No. I actually probably should have looked at that before I made this decision right here, right? Because if one of these factors did end up canceling, would I have kept that value in the list of vertical asymptotes? It would have been a hole instead. So something to keep in mind. Since nothing cancels out, there are no holes. Okay? So we don't have to remove any points from our graph at the end. All right, what about the other asymptotes? So we have up there horizontal asymptotes and oblique asymptotes. We've got to figure out something in that realm of stuff. Anna?
For the horizontal asymptote, you have to look at the degree of the first, so like the highest degree.
Okay.
And then look at the denominator.
Good. So we look at the degree. Now, don't be confused right here because you look and there's an x squared and an x squared and you want to say they're the same. The degree is like after it's all multiplied out. So in its unfactored form, what's each degree? So in the numerator, what's our degree? 2. Okay, because we have an x squared. In the denominator, what's our degree? 3. Okay. So who has the greater degree? Denominator. Keelan, what does that tell us? Good, but there is a horizontal asymptote specifically at 0. And what does that mean about oblique asymptote? There isn't one. If you end up like a horizontal line, you don't end up not like a horizontal line, right? So it's kind of a one or the other kind of deal. I either have horizontal end behavior or I don't. So since I found a horizontal end behavior, there is not an oblique asymptote. All right. X-intercepts. How am I going to go and find those? What can I focus on? Numerator, and doing what with it? Set it equal to 0, right? Because basically, if I set y equal to 0 in this function, when will this fraction equal 0? Only when the numerator is equal to 0. So I've got to do a little work for this. I'm assuming you guys can solve this equation. So I get actually two values for x. I get x equals plus or minus root 2 over 2. Someone tell me what approximately is root 2 over 2. You can tell me with a calculator on here, just for our graphing purposes. .707? Okay. So we know when we go to put them on the graph, we want to put them around .7. Okay. All right. What about Y-intercept? Oh, sorry. Yeah, Maya.
If the vertical asymptote is at 0,
Mm-hmm.
and that means that you can't touch the 0 line,
Uh-huh.
how can we have an intercept?
So X-intercepts, so along this axis, our vertical asymptote will go along this axis. So right now, our vertical asymptotes, we'll go ahead and mark this stuff on the graph to make it more clear. Here's our x equals 0. Here's our x equals 2. We have a horizontal asymptote. Oh, thank you. I'll fix it. At y equals 0. So remember what we said about, now I get your question a little bit better. What we said about asymptotes was vertical asymptotes can't be crossed. They are places where the function is undefined. However, what are horizontal asymptotes there to represent? End behavior. So could they possibly be crossed while the graph is doing all the stuff the graph is doing? Yes. Are they always crossed? Just kind of depends on how the function works. But they could be crossed. Its real purpose is to tell us that once we're done doing all the stuff that's going to happen, it's going to follow these lines somewhere out at the end. So really important for us to understand how to find them, but almost more importantly, understand conceptually, vertical ones you literally cannot cross because the graph is undefined there. You can't plug in that x value and get a y value. But horizontal ones are really there for end behavior. Tell me what's going to happen at the ends of my graph. Does that help? Okay. And thank you for the correction. It would have been really bad if I tried to graph it within the wrong spot. It wouldn't have made sense. All right, and so then I have these two x-intercepts. We said that root 2 over 2 is about 0.7. So I have an x-intercept at like positive 0.7 and at negative 0.7. Okay. What about y-intercepts? So how am I going to find it? Zeke? There's none? Okay, so how does he know that there's not a y-intercept? Evie? Good, the vertical asymptote's on 0. So you can either see it visually on the graph. You could have tried to go plug in 0 for x, and you would have had a 0 in the denominator, and it would have been undefined. So we don't have one. All right, so here's the deal. This is what we have. Helpful, somewhat, okay? At least we have some guidelines. We know there's going to be like something over here. It's going to break right there, something in this middle here. It's going to break right there, something else over here. And we know at the ends it'll follow these horizontal lines. But then we want a way to sketch the graph without having to plug in a bunch of numbers to this and try to do all these crazy calculations. So what we're going to do is we're going to just do an analysis of if points on the graph in certain areas end up above or below the x-axis. Okay? So the things we want to look at. So I'm going to draw us a little. Thinking about this as my x-axis, there are some places that it's important to know that it's broken up and why. Vertical asymptotes are important to know that it's broken there because I don't cross there. So the graph could behave one way on one side of it and a completely different way on the other side of it because they're completely disconnected, right? So vertical asymptotes are an important place for me to look at what's happening on one side of it versus the other side of it. Okay? So that would definitely mean at negative 2 and also at 0. The other places, though, it's important for me to think about what's happening on each side of it are the places we have x-intercepts. Okay? Because when you have x-intercepts, the graph has to touch the x-axis at that point, right? Which means it either came from down below the axis up to that point to touch it, or it came from up above the axis down to that point to touch it, right? And once it touches it, what are the choices for how the graph can behave? See? So it could either turn around and go back up above it, or kind of like a cubic looking type of thing, it could go down through it, right? And so we want to know, after it comes to that point, what was it doing before that? Was it coming from the negatives or the positives to that 0? And then once it hits the 0 after it, does it go back up to the negatives or does it go back down to the positives? Okay? So the way we want to split up our x-axis is into sections based on vertical asymptotes and intercepts, because those are things where the graph would be broken apart, or places where they would come to the 0, and we'd know that on each side of it, it was either below in the negatives or above in the positives. Okay? So we had a point at about negative 0.7 and about positive 0.7. So what I'm going to do my analysis is I'm not going to make an exact XY chart. I just want to know when I plug in an X value in this area, does the Y turn out to be positive or negative? The reason I don't really care the exact value, don't write this part of the graph down, but just allow me to show you guys. If I know there's a branch of the graph on this side of negative 2, but the graph never hits, because there's no X-intercept, right? It doesn't hit here. Does it cross through the X-axis on the left side of negative 2? No. So knowing that the graph has to follow the asymptotes as guidelines, what are kind of my choices where I could sketch a piece of this graph? What's it going to have to look like? If we know it follows the asymptotes, but we can see because there's no X-intercept over here that it doesn't cross the axis, there's only a couple of choices of how this can look. What are my couple of choices? Any ideas? Jarrett? Like this?
To the right.
But I only want on this side of the asymptote.
To the left, like go on the left.
Here?
Yeah, and then go on.
Okay, gotcha.
And then the other way.
Or like this. Okay. Do you guys see how he's picking up on, like, it's got to kind of do one of those two things? The exact points I'm not sure of, but would you guys agree that if the graph doesn't cross the x-axis, but it's got to follow those asymptotes, those are kind of the only ways that the branch can kind of fit there? So do I really care about the exact y values if I'm just trying to figure out where the branch is approximately? No. I care about, are the y values positive, because they would all be up here, or are they negative, because they would all be down here? So you're just kind of doing a positive-negative analysis. So all you have to do is think of numbers smaller than negative 2 and what would happen if you plugged them in here. So in here in the numerator, so you plugged in like negative 5, okay? You'd square it and get a positive, but then it'd get multiplied by this negative. So that would make it a very negative number, and you'd add 1 to it. So it would end up being negative, okay? Here, when you plug in negative 5 to x squared, what's going to happen to it? Positive. And then when you plug in negative 5 in this x plus 2 factor, what's going to happen to it right there? Negative. Overall, does this work out to be a positive or a negative value? Positive, right? So I know that everything over here is positive. So that tells me, coming back to Jarrett's possibilities, that it's not going to be down here because the y values don't turn out to be negative. They all turn out to be positive. So the branch should be following the asymptotes above the x-axis where y values are positive. Okay? Yes, Aaron. Yes. Okay, so again, vertical asymptotes are places where the function is undefined. Horizontal asymptotes are to describe end behavior. So lots of stuff can happen in the middle where it could cross, it might not. It's just saying how it's going to behave at the ends. Okay? So you have to distinguish what the difference between each asymptote is, because they each signify something different. Is that okay? Okay.
So it can cross the x-axis,
Uh-huh.
but it's describing the
End behavior. So at the ends of the graph is going to start behaving like this horizontal line.
Oh,
Okay? It doesn't tell us anything about what's happening while all this other stuff is going on. It only tells us, okay, once you get past all that crazy stuff, when you plug in bigger numbers for x or really small numbers for x, your graph is just going to kind of settle down to look just like this. Okay? Is that all right? All right. So then on the other side of the asymptote, okay? So we've done the left side of the asymptote that's at negative 2. It's going to, again, have to follow the asymptote, which means it's either going to shoot up along the asymptote or shoot down along the asymptote. But there's also an X-intercept right here, which means it's going to have to eventually come to that X-intercept, right? So the question is it this piece up here, which means all the X values in here would produce positive Y values? Or is it going to look something like this, which means all the X values in here produce negative Y values? So again, what I care about is if I plug in an X value that's between -2 and -0.7, do I end up with a positive or a negative result? And that will tell me which of these types of things I should draw there. Okay? So notice I've drawn both the possibilities, right? Those don't both belong there. Just kind of brainstorming and showing you guys what should happen since this is our first time doing it. So I want to think of a number between -2 and -0.7, maybe like -1, okay? And think about what would happen if I plugged that in. So in the numerator, if you plug in that number, do you get a negative or a positive value? Sorry, what? Negative? Okay, fine. Right here, when you plug into this factor part, -1, you get a positive. And right here, when you plug in -1, positive. What is this going to result in when all is said and done? A negative value. Okay? So which branch should I draw? The one I drew up here above the axis or the one from below the axis? Below, because the Y values are all negative. Okay? So I'm just going to go along the asymptote and come up to that intercept. Again, am I graphing exact positions for everything? No, but do I have a really good idea of how this graph is behaving in general? Yes, because of all the little guidelines that we put on there for ourselves. Austin?
So you drew it, then it stops at the X.
Yeah, and then I have to know what happens after that, because I don't know yet. So what could happen now that I've reached this X-intercept? So I could keep going up, which means when I plug in any of these X values in here, I'm getting positive Y values. Or what else could happen? I could turn around and go back down, right? I might not go all the way through the X-axis. I might just hit that point and go down. So again, I have to know when I plug in these X values, do I get positive Y values or negative Y values so I know whether the graph goes through and follows this asymptote up, or it turns around and follows the asymptote down. Okay? Explain?
If the horizontal asymptote describes the end behavior, why is it following the vertical?
So we're not at the ends yet. So the horizontal asymptote is only there for the things at the very end of the graph. So there's going to be a bunch of stuff that's going to happen in between, and we're only going to follow this structure at the very ends of our graph. So here and here. Is that okay? It has to follow the vertical ones too, because remember, it's just that one value that breaks up your graph. So if my graph has to do something, but can't cross this, but every other value works, it's either going to be going like this or like this. Okay? All right. So I have to plug in something between -0.7 and 0. Maybe I would do like -0.5. Okay? This one might take a little more work. I don't know. So -1/2 squared is like 1/4, and 1/4 times -2 is -1/2 plus 1 would actually be a positive this time. Okay? What about when I plug a negative into this 2x squared part? Positive. Okay. What about when I plug -1/2 into this x plus 2 part? Positive. What's this going to result in? Positive. Okay. So should I turn around and go back down, or should I go up and then follow the other side of the asymptote? Up, right? Because I have positive y values now from that point forward. So it's kind of like a little cubic thing happening in there. Okay. Now I got to know what's happening on the other side because I have this other X-intercept. So now on the other side of the asymptote, is it going from the negatives up to that X-intercept or from the positives down to that X-intercept? So now I want to plug in positive 0.5 because it's between those two values. So again, that's a fourth times -2 is -1/2 plus 1. That's a positive. That would be positive. That would be positive. So again, it would be positive. Okay. So that means positive values between the asymptote and the intercept. Okay. See?
Should we plug in Y now?
Should we plug in what now? Y. 1. Yes, after 0.7, we can plug in anything. You actually don't even have to literally plug in a number if you're good at like the abstractive idea of like, well, if it's bigger than 0.7, like clearly if I plug in something big and positive here, it's going to make a big number times a negative is going to make something really negative. When you add 1 to that, it's still going to be negative. So like this would be negative now for that value. Here you're squaring everything. This factor is always going to be positive, right? And here, if I have a positive being added with another positive, it's going to be positive. So overall, this is going to result in a negative, which means, and this is where it gets a little bit, this is kind of the hardest situation as far as drawing. I know it goes through the axis, but what else do I know based on the end behavior for this graph? CJ? It has to follow the asymptote. So what must happen somewhere for that to occur? It's got a curve, right? And just kind of like come back to it. Do I have any idea how low it goes or anything like this? No. Do I expect you guys to know that? No. I just want you guys to be able to draw the general structure of the graph. Okay? So, I don't know. I'm just going to make sure that it curves. Oh, not like that. That would be a little intense. I would make sure that it curves back towards the asymptote. Damien?
Well, isn't it if you put a negative on the denominator, won't it become a negative and a positive?
Right here, I was only looking to plug in numbers in this area, which is numbers bigger than 0.7. So at this point, I was only looking at plugging in positive numbers. In these other areas, I did consider plugging in negative numbers. I did, and that's why sometimes these values were negative and sometimes they were positive. This one would always be positive because it had the x squared. This one was negative when I was plugging in anything that was further than negative 2. So it was only negative when I plugged in these values. Okay, so it depends on which area you're plugging in for x. Okay? Is this all right with everybody? So do you see why this stuff was important for us to understand how to get? If we didn't have this information, we wouldn't really know what to even go and analyze. Okay? All right, you guys ready to try another one? Yeah, let's see. All right, so here's what I want you guys to do. I'm going to go ahead and factor the denominator if it's factorable. Hopefully it's factorable. Yeah, okay. All right, and I want you guys to see if you can figure out this information. All right, so I'm going to give you guys a couple of minutes to see if you can fill in all the information about asymptotes, holes, and intercepts, and then we'll go back through the analysis again together to finally draw the graph. If you're ahead of us and you feel really comfortable with how to analyze it and fill in the curves, then go for it, and then you can just check if you're right as we do it. But if you're like, I'm not even there, then don't be there yet. First check and see, can you get all this information, and we'll walk through then just sketching the graph one more time, okay? Okay, so check the info. Your horizontal asymptote should be y equals 3 over 2. There was same degree numerator and denominator. The lead coefficient in the numerator was 3. The lead coefficient in the denominator was 2. Okay? Because it was 3x squared over 2x squared. Okay, if you think about what it looks like multiplied out. That means there's no oblique asymptote. For our vertical asymptotes, we have one at negative 1/2 and one at 3. One from each of the factors that are here. Neither of them got canceled out. That's why they were both vertical asymptotes and there were no holes. Okay? Our x-intercepts, if we took those factors from the numerator and set them equal to 0, we get that x could be 0 or x could be 1. So we have x-intercepts at 0, 0, and at 1, 0. And if you plug in 0 for x and figure out what y, you also get 0, or you might have just known because you get that if it crosses at 0, 0, it's both an x and a y-intercept. And that's our intercept there. So I'm going to go ahead and mark all this stuff on the graph. So if you haven't already, mark each vertical, horizontal asymptote and every intercept that you have. Anna? Setting the numerator equal to 0. Okay? Because if you plug in 0 for y and try to solve for x, the fraction will only equal 0 when the numerator's value is equal to 0. Okay? So when I go to do my analysis and I want to see where it's positive and where it's negative, how do I want to break up my x-axis? Where should I kind of think about the divisions being? Jarrett? Okay, are those the only places? So I get he's right that we want to break it up at the vertical asymptotes, but is there another place where you could cross from being in the negative realm to being in the positive realm? Yeah, at 0 because there's an x-intercept at 0, and where else? At 1. So we have to see what's happening between all of those. Okay. So again, I'm just thinking about what if I plug in a number in this area? Do I end up positive or negative? Let me draw it in. Okay. So if I plug in something really negative, okay, negative 100, whatever you want to think about. This first factor right here, negative. This factor right here, negative. This factor right here, negative. And this factor right here, negative. After all those things are multiplied together, will it produce a negative or a positive? Positive. So, asymptotes here, you don't cross the axis. It kind of made sense that it should end up here. Okay. Because if it followed this and then followed this, it would have had to cross here somewhere, right? And we don't have an x-intercept. So that really works with how the graph looks here. It makes sense. Okay. So then from this asymptote to this x-intercept, is it coming from here? Is it coming from here? And we can cross the horizontal asymptotes, right? They're just more for end behavior. Okay. So what's happening between negative 1/2 and 0? So think about if you plugged in something like negative 0.2. Okay. So here it would be negative. Here it would be negative. Here, negative 0.2 times 2 is like negative 0.4 plus 1. That would be positive. And here it would be negative. So what would this result in? Only one positive, 3 negatives, so it'll be negative. Okay? So that means it comes from here in the negatives till it gets to that point. Okay? Then what about between 0 and 1? So what if I plug in like 0.5? So here would be positive, here would be negative, here would be positive, here would be negative. What is this going to result in? Positive. So between 0 and 1 it's positive, so I'm guessing it comes up and turns around. I don't truly know if it crosses this or not. You could plug in and find an exact value if you want, but I'm not going to judge on that. If you got that it came up here and had to turn around to come back to the next intercept, you're good. Okay? So then from 1 to 3, say I plug in 2, positive, 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 negative. That overall will result in a negative. So this is going to come back through here. It's not a perfect parabola. It's definitely not symmetrical, but we get the idea of what's going on. Any guesses before I plug in what's going to happen after the number 3? Hannah? It's going to be positive. How do you guys think that she knows that? Jarrett? So one way is to check the numbers, which we'll do in a minute. But also look at the graph. You have to follow this asymptote here or here, and you have to end up coming really close to this line here. If I'm following this down here, but I'm eventually going to be up by this line here, I would have to cross the x-axis at some point. True? Do I have any x-intercepts over here? No, which means the only logical way that this is going on is if it's going like this. And if you plug in a big positive number, you can see that. So if I plug in like 10, positive, 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 okay, and it would be positive. Okay? Damien?
How do you know that you turn around from 0 and you go to 1?
Because between 0 and 1 it was positive, but I know I'm at 0 right here and I'm at 0 right here. So the only way for it to be positive between them but hit both those points is to eventually turn around and come back to the other one. Okay? Because it's got to be above the x-axis, but it still has to hit both those x-intercepts. Okay, let's talk about one more. Let me see if this is the one. Oh, yeah. This one. So this says 5x squared if you don't have the note taken here. Over 3 plus x or x plus 3. All right, what's different about this one than the other two that we tried? Damien?
It's going to have an oblique.
Good. It's going to have an oblique asymptote because the numerator has a higher degree than the denominator. So horizontal asymptote, not happening. Oblique asymptote, here's how I have to figure it out. I have to divide. Okay? So I have to do 5x squared divided by x plus 3. Okay? Remember with our division, placeholders for any spots. Okay? Alicia. It says 3 plus x. I just wrote it with the highest degree of x first. Okay? Damien? In this case, you could. I'm going to review long division because if it was like 5x cubed, longer polynomial, and then it was divided by like x squared minus 3, you couldn't use synthetic division. So you can in this case because it's just divided by x plus 3. But I'm using long division just in case someone forgot how to do it because you could at least use that all the time if you had to. Okay? So x goes into 5x squared how many times? Like what times x makes 5x squared? 5x. Okay. That makes 5x squared plus 15x. And then remember with division we're subtracting this stuff. What times x makes negative 5x? Negative 5. Okay. So negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. We get a remainder of 15. Okay. So technically, if we divide this out, our function becomes 5x minus 5 plus 15 over x plus 3. Yes?
Wouldn't it be negative 15 or negative 5?
Oh, yeah. Thank you. 45. Okay. Thank you. All right. So here we go. So this is our line. So when this divided out, it equals this. These are the same thing. Okay? It's like saying 5 divided by 3 is equal to 1 and 2/3. Okay? This divided by this is equal to this plus this remainder right here. But when we're looking at end behavior, remember, we're only thinking about what happens when you plug in really big values for x. Any remainder has a higher power in the denominator, and what happens to fractions that have a higher power on x in the denominator when you plug in really big values for x? They get really small and close to what? 0. So when we're looking at end behavior, we don't care about the remainder. It's not that the remainder doesn't exist. It's not anything like that. We just don't care because we're only thinking about this one situation, and in that one situation, this becomes practically 0. So it's really this that's important. So our oblique asymptote is this line. So I'm actually going to go ahead and number my y-axis by 5s. Okay? But I'm going to keep my x-axis numbered by 1s. So my oblique asymptote is this line. I need so many points because I can't draw a straight line. Just have rulers and flat paper, stuff like this. You'll be fine. So instead of a horizontal asymptote, you get this idea going on. Okay? Vertical asymptotes, same way that we always used to be. Where's our vertical asymptote for this equation? X equals what value? Negative 3. It's what makes the denominator equal to 0. Okay. Are there any holes? No. Do we have any X-Intercepts? So can our numerator be equal to 0? Yes, at what X value? 0. So our X-intercept is 0, 0. And then do we have a Y-intercept? Yes. What is it? 0, 0. Okay. So I'm going to plot my vertical asymptote and my intercept. So there's good news and bad news in this problem. The good news is there's a lot less separations than we had to do before, so we don't have to test as many areas. Sometimes that makes it a little more vague and harder to figure out what's actually happening in the graph. Anna, question? Say it again, please.
Can you go through the oblique asymptote?
Yes. just like a horizontal asymptote. It's only there to help you know what's happening at the ends of the graph. Okay? All right, so in this graph, I only care what's happening on each side of -3 and at 0. I understand the oblique asymptote crosses the x-axis, but do I care about that? No, because the oblique asymptote, like Anna just pointed out, is only there for end behaviors. It doesn't split anything up. Okay, so when we look at this function, when we plug in a number smaller than -3, okay, we would get a positive over a negative, which results in a negative. No, my x-axis is by 1s. Only my y-axis is by 5s. So it's negative. This actually makes sense because do we cross the x-axis at all over here? No. So think about it. If you're going to follow the asymptote, you have to be going there or there. But your end behavior is supposed to follow this slanted line that's on here, right? So the end of the graph either has to be like right here or right here on one side of that line, which means my most likely branches are either like this or like this. Same as before, it's just that the line's not horizontal. It's slanted, okay? Do we have any X-intercepts on this side of -3? No. So is this branch even really a possibility? If I can't cross the x-axis, would I be allowed to be up here and then come way down here? That's not possible. Those are contradictory, okay? So you would have to draw your branch down here, okay? If you do the sign analysis for the next one, I think you end up going like this, okay? So it ends up looking like this. So what I want you guys to do, I want you to try every problem in the homework. What I would define as try is that you have all of these things listed out. You have all of these things marked on the graph. You've made something like this, and you've done your best to sketch in the curves. And on Tuesday, we'll focus on sketching in more curves, okay? Both. So we did the chart for number 5, so you just have to fill in the investigation, and then work on the graphs for homework 6.